Mensuration Mobile, quality e-learning experience on the go.
Yeah, welcome back to the class. Our topic for today is captioned Mensuration 3. Mensuration 3. And this time around we'll be dealing with surfaces, the three dimensionals, areas, and volumes of simple solids. Okay, and we'll be talking about different shapes like the cuboid, the cube, the cone, the circular cone, and we'll be considering their volumes too. At the time we'll still talk about the pyramids. Alright, okay, I want us to talk about the cuboid now. The cuboid has a surface area. Okay, a cuboid with length, x centimeters, and the width y centimeters, and a height, of z centimeters. We'll have a total surface area as follows. 2 times xy plus yz plus zx centimeters squared. Okay, so how do we justify this? Assuming we take this to be a cuboid. Alright, manage this to be a cuboid. And just try to get something that looks like it. Wow. And so we have its mirror image. Okay, I think this can help out. And then we have this height of z centimeters, and then we have the length of x centimeters, and then we have this width of y cm. Okay, and now the possible combinations that could give you the total surface area. You know that each of the surface area consists of either y and x, or z and y, or z and x. Okay, so and since these are the possible combinations for each of the sides, okay, so it then means that each of the sides are repeated twice, because the surface area here, okay, can also be seen only at the back of the box. Okay, and then the surface area at this point can only be seen again at the back of this box here, and then the top and the bottom are like so. Since there are 2 tops, there are 2 bottoms, there are 2 sides each, that is why you have these 2. Okay, multiplying the possible surface areas. Okay, so that's why we have the total surface area is this. Okay, that's the number 1 property I would like you to note. And then the number 2 property here, number 2, the total surface area of a cube. Total surface area of a cube, okay, with sides, a cube with sides x. Alright, that is, you're talking of a cuboid. Okay, with x, y, and z. If it were to be a cuboid, you know the difference. The difference is just that a cube, all the sides are equal. Okay, is 6x raised to the power 2. Okay, So like I said, in the case of a cube, we have all the sides being equal. Your cube of sugar is a good example of what the cube looks like. Okay, and so in a cube, all we are saying is that all we are saying is that x, y, and z are all equal. That is x is equal to y, and then y is equal to z. And then this changes our formula from 2 xy, zy, and zx. Okay, since they are all equal, it becomes xx and xx. Okay, it becomes xx, which is squared, xx squared, xx squared, and so on. And so this becomes 2 into 3x squared. Okay, 2 times 3, 6x squared. Okay, this is how we came about this formula. And since you've been clarified about this, we can go on and talk about other circular shapes. We have the cylinder, and then we define the cylinder. The area of a cylinder, a circular surface of a closed cylinder with radius r is given as r equal to pi r squared. Okay, for areas of a circular surface of a closed cylinder. Alright, okay, it's given as this, as well as area of the curved surface of a cylinder with radius r and height h. Okay, is given as 2 pi rh. You see, all these formulas you need to get them down offhand, so that at any point in time you can be able to record them. I don't have sufficient proof to prove all these formulas, but I will advise you to memorize them so that you can apply them whenever you encounter operations that you need to apply them. Okay, so since we have these as areas of for curved surfaces, this one is for closed surfaces, for curved surfaces, and these are the properties of cylinders. Okay, they have curved and closed surfaces. So all we are saying is that hence the total surface area of a cylinder, surface area of a cylinder, will be equal to 2 pi r squared plus 2 pi r h. Okay, all right, and so this will give you 2 pi r plus h. All right, okay, we have the right circular cone. Just be very meticulous about it, and always be eager to note when terms are used, so you can be able to know which properties are being demanded of you. and which of the formulas you need to apply. Alright, I'll try to draw my cone like this. I believe you understand. Okay, and then I have this line running through the triangle where I have the radius, and then the height of the cone flowing from above to below. Then I denote this as H, L, and L. Okay, so we can obtain area of curved surface to be equal to pi RL. Okay, and the area of closed surface of a circular cone to be equal to 2 pi R squared plus pi RL. Okay, so it's as well written as pi R plus L. Don't bother about the too many formulas we have here. By the time we start to apply them, and with your subsequent practicing using them, you will get them down into the memory lane easily. Remember, practice makes perfect. And so let's talk about another figure called the sphere. The sphere. Alright, the sphere has a surface area. Of 4 pi R squared. Alright. Okay, so we have given the areas of these figures, so we'll go over to stating their volumes, how to compute their volumes. Okay, I will state that quickly. Volume of a cube with edges, x is equal to s cube. Remember what we said about the cube. And then volume of a cuboid with edges x, y, z, x, y, and z is equal to x times y times z. And then volume of a right circular cone of height h and base radius r is equal to 1/3 pi r squared h. So the volume of a pyramid is equal to 1/3 base area times height. Okay, and then we'll go over to volume of a sphere. Volume of a sphere. These are objects we've talked about before. Okay, it's given us 4/3 pi r cube. Okay, so we'll try to apply these in examples. We shall try to apply these in examples. So for the first example, let's try to find it. Example 1. Example 1 states that a closed box is in closed box is in the form of a cuboid, okay, with dimensions with the following dimensions: 16 cm by 10 cm by 7 cm. Okay, and the question says A, find the total surface area of the box, and B, you should find the volume. Find the volume of the box. Okay, so how do you go about this? This is very simple. Of course, you can see, alright, the total surface area of a cuboid is stated as 2 times xy plus xz plus yz. Okay, I think that's what we have here. Okay, this is for the total surface area. We are using this equation, I labeled 1. Alright, and then from this point we can say that here x is equal to 16, and then y is equal to 10, z is equal to 7, all in centimeters. Okay, so therefore applying the formula, we have that 2 times x, y 16 and 10 plus xz 7 and 16 plus yz, you have 10 and 7. Okay, and then we have 2 times 160 plus 112 plus 70, and this is equal to 2 times, when you sum up these numbers, you have 243, and which is equal to 684 centimeters squared. Okay, so therefore this is the total surface area of the cuboid. Alright, so we'll go ahead to find the volume of the box. Number 2, solution 2, we have to find the volume of the box. Alright, so how do you go about that? Remember, the volume of the box is, the formula for it is given as x, y and z. So therefore what we have to do, since we know our x to be 16, and then our y to be 10, and then our z to be 7, just multiply all of them, and so we have the volume of the box to be equal to 1120 centimeter cube. Okay, observe that areas are always in centimeters squared, and then volumes are in centimeter cube. So let's try to do some more examples before we round up for the topic, because we are already done for the topic. Okay, let's take some more examples, and then example 2 says that a circular field with diameter (70 meters) is surrounded by a circular path 3.5 meters wide, as will be shown below. Okay, and then we are told to calculate the area of the part, and as well as the volume of paint, the volume of paint in liters, required to cover the part. Okay, required to cover the part to a thickness of 1.0 centimeters, and you're given pi here to be equal to 22/7. Alright, so we need to have a pictorial diagram of what we're saying here. Here you're told that a circular field with diameter 70 meters. Okay, assuming circular field with diameter 70 meters is surrounded by a circular part 3.5. okay, and then alright, let's have a picture of what we are saying here. If this is the circular field we're talking about, okay, and then it is surrounded again. It is surrounded by a circular part 3.5 meters wide. Okay, this is the other circular part that surrounds it, and you're told this circular part is 3.5 meters away from here. Okay, and then you're told that the diameter of this cycle is 70, and which means that the radius at this part is 35 meters. Okay, because 35 gives you a total of 70 meters on the diameter. Alright, and so the question now is calculate the area of the part. Calculate the area of this part. You know, so one thing you have to bear in mind is, in order to find the area of this part, we have to subtract the area of the big cycle from the area of the small cycle. Okay, and then for the bigger cycle, the radius r becomes 35 plus 3.5, and the smaller cycle, the radius r becomes 35 meters. Okay, so that means big r is equal to 38.5 meters. Okay, while small r is equal to 35 meters, and then our pi is given us 22/7, and then the diameter d is equal to 70 meters. Okay, so solution 1. Solution I. Okay, total area of cycle minus area of enclosed cycle will give us the area of the part. I just wish you understand this. Okay, so how do we go about the total area of cycle? Okay, area of cycle is already given us pi r squared from mensuration 2, and we'll just apply it here. Okay, I remember if it is for the big cycle, r is equal to 38.5, and then for the small cycle, r is equal to 35 meters, all in meters. And so area for the cycle, I mean the big cycle, okay, will now be equal to 22 over 7. R squared is 38.5 R squared. Okay, if you carry out this computation, you have 4658.5 meters R squared. And then area of enclosed cycle, or the small cycle, will now be equal to 22 over 7, and then the difference of radius of 35 squared, okay, which is equal to 3850. So that therefore area of packed which is equal to area of big cycle minus area of small cycle okay, will now be equal to 4658.5 meters squared minus 3850 meters squared. Okay, if you do your subtractions very well, you have 808.5 meters squared as the area of packed. Okay, and then question B says what volume of paint will be needed to increase the thickness of the area of the packed. Okay, solution B, volume of paint needed to cover the packed. Okay, and to make a thickness of 1.0 centimeters. All right, I think we need to do some little conversions. We need to do some little conversion. We need to convert centimeters to meters, and so 1.0 cm is equal to 0.01 meters. You can go back to your table of conversions or table of relationship between quantities, and then volume of paint will now be equal to 0.01 times the area to be applied to be painted, okay, which will give you 8.085 meter cube. Okay, but the question says the volume in liters, the volume of paint in liters. So we have to convert from meters squared to liters. Okay, and then if you go back to your table of relationships, you find that 1 meter cube is equal to 1000 millimeters cube, which is equal to 1000 liters. Okay, and therefore converting this to liters, you have to multiply 8.085 by 1000, okay, which will give you 8085 liters. Take another example. Example 3. Okay, here we are told to find the total surface area. And B, we are told to find the volume of a solid right cone. Of radius 3.5 centimeters, and the height of 12 centimeters. Okay, and you can take pi to be equal to 22/7. This is my 7. Alright, so find the total surface area. How do we find the total surface area of right side, a solid right cone? Let's go back to our table of formulas where these were listed. Okay, I think I can see that of a right cone, a right circular cone. Okay, we can find the volume using 1/3 pi r squared h, pi r squared h. Okay, so solution, volume for a solid right cone is equal to 1/3 pi r squared h, and then the total surface area, if you go back to our table of formulas, is given us the surface area. Okay, let's check back at our formula. It's given us pi r plus l. Okay, I think I need to show you where this is. Alright, okay, that's the total surface area we're talking about. Okay, let's get back to our slide. Alright, so we can quickly find the volume. Okay, because we have pi to be equal to 22/7, and then we have radius r to be equal to 3.5 cm, and then we have the height to be equal to 12 cm, and so the volume, which is equal to 1/3 pi r squared h, is equal to 1/3 pi is 22/7, r is 3.5 squared, and then h, the height, is 12 cm. Okay, alright, and so if you carry out such a computation, you have 22 times 12.25, which is 3.5 squared, and then times 12 all over 3 times 7. Okay, and then on the next slide, if you divide out carefully, you will have your outcome as 154 centimeter cube. And I don't intend to waste your time. It is in cube because we are talking of volume. And so let's go back to finding the total surface area, okay, which is defined as pi r and then r plus l. Okay, already we have pi 22/7, we have r to be equal to 3.5, and then l, we don't know what this is. So how do we find l? Assuming the cone we are talking about is of this type, okay, and you're told that the height is 12 cm, and then the radius r at this point is 3.5 cm. Okay, so how do we find the length here? How do we find the length? We can use by Pythagoras. Okay, we have that the length L squared is equal to the radius squared plus the square root of the height. Sorry, the height squared. L squared is the radius there is 3.5 squared, and the height there is 12 squared. Okay, L squared is equal to 3.5 squared gives you 12.25 plus 144, and so L squared is equal to 156.25, so that L being the length is square root of 156.25, and so L will be equal to 12.5 centimeters. Okay, now we have L, so we can compute for the total surface area pi arrow arrow plus L. So therefore pi arrow plus L, which is total surface area, is equal to 22/7 plus the radius 3.5 times 3.5 plus L 12.5. okay, and so we have this to be equal to 22/7 times 3.5. When you add these two sum, you have 16, and multiplying the three of them, you have 1, 2, 3 to all over 7, which will give you 176 centimeters squared. Alright, as the total surface area. I hope you wouldn't find this difficult to. Okay, that takes us to probably the last example for this particular aspect of our study. We have example number 4. Okay, and we have a pyramid. We have this pyramid. Okay, I'll try my best to get the best shape. Alright, we can manage this. We have this pyramid, and you're told that the length on this part is 12 centimeters, and then here you have 10 cm. Okay, and then if I should label this the square of the pyramid A, B, C, and D. Okay, I'm talking about the square inside the pyramid, the square base. Okay, this is a square base. This is the square base. Alright, I hope I don't make mistakes again. Alright, this is the square base, and denoted by A, B, C, and D. Alright, and the pyramid have triangles P, 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 and P. Okay, and so the question states as follows: the net of the pyramid below with squares, with square base A, B, C, D of side 10 cm, and triangular faces with height of 12 centimeters. Okay, hence you're expected to calculate the following. Alright, I believe we said nothing about our pyramid while we are trying to develop formulas. Yes, we shouldn't have said anything at all, because a pyramid consists of triangles and squares. So if you've learned previously how to work with triangles and squares, you can apply both principles to obtain the surface area of a pyramid and the volume. Alright, okay, but I think the volume was stated, but nothing about the surface area, because the surface area has to do with a combination of other objects like the square or the rectangle and the triangles. Okay, so we are told to calculate the following. Number one, we are told to obtain the total surface area. total surface area, and number 2 we have to find the volume. Find the volume of the pyramid. Okay, so how do we go about this? So the total surface area, we know that the surface, the pyramid consists of 4 triangles and a rectangle, 4 triangles and a square rather. Okay, so therefore solution A, solution 1, the total surface area will be equal to 4 times area of the given triangles, okay, plus area of the square. Okay, so if we want to find the total surface area, we'll find the area of one of the triangles, and since there are 4 triangles, we multiply by 4 and then we add it to the area of the square. So I guess we should start and how do you go about this? Look at the triangles very well. You find out that the triangles have a base of 10 and a height of 12. Okay, from the pictorial diagram, that means base of triangle B is equal to 10. Okay, as observed from here, base of triangle 10 centimeters, and since the squares are of the same, so that means each of them having their base on the square will be 10 centimeters each. And then we have the height to be 12 cm also in the diagram there. So therefore 4 times half base times height, okay, plus area of square, which is length times breadth, will give us the total surface area. And this is as good as saying 4 times half base is 10 and 12, okay, plus 10 times 12 length times breadth, sorry, 10 times 10 because it's a square. Okay, length is equal to 10 and the breadth is equal to 10. You know, a square has all sides to be equal, and so you have 4 times 5 times 12 plus 100. This gives us 20 times 12 plus 100. Here you have 240 plus 100, which is equal to 340 centimeters squared. Okay, to be the total surface area of the pyramid. So we go over to finding the volume of the pyramid. Finding the volume of the pyramid, solution 2. Solution 2, we need to find the volume of the pyramid. Volume of pyramid, okay, and from the formula it's given as 1/3 base area times height. Okay, we know the height to be equal to we know the height of the triangle, but we do not know the height of the pyramid. We need to find out the height of the pyramid, but we know the height of the triangle. Okay, so how do we determine the height of the pyramid? You can bring out one side of the pyramid so you can be able to derive the height. And so remember that the height of the triangle is 12 cm, okay, and the base is 10 cm. So how do you find the height of the pyramid at this point? Okay, so how we do this is this. we have to use the Pythagoras theorem, which states that from this point h squared is equal to 12 squared. Sorry, before I use 12 squared, okay, 5 squared, okay, by Pythagoras. And then we have h squared, 12 squared is 144, and this is 25, and h squared, when you subtract this, you have 119, okay, so that h will be equal to square root of 119, and then h is equal to 10.91 centimeters. Okay, so this will help us determine the height of the pyramid itself. Okay, the height of the pyramid itself. Okay, why we used 5 is because considering at the point where we cut one of the pyramid, okay, we have 2 sides, and then cutting into equal sides, 5 cm and 5 cm. Okay, good. So all we are interested in is on this on one side of it, okay, where we already have a height of 12 cm on this part. Okay, we already have a height of 12 cm here, and then we have a base of 5 cm, and then this is the height of the pyramid for which we are looking for. Okay, if I should denote as A, B, and C, so it implies that AB squared is equal to BC squared plus AC squared. Okay, and then from this point, we know that AB squared is 12, BC squared is h squared, and then AC squared is 5 squared. Okay, for which h squared is equal to 12 squared, okay, minus 5 squared, you know, switching formulas. Okay, that was how we arrived at this point. Okay, I believe by now you should be conversant with Pythagoras theorem, so that manipulations using them wouldn't look like magic to you. So therefore, since you have the height of the pyramid, we can go ahead and find the volume of pyramid. Okay, remember the volume of pyramid has already been stated as to be equal to 1/3 base area, okay, times height. Alright, so what's the base area? Base area is equal to the area of the square, okay, because the base is a square. Okay, for which we said it is length times breadth, 10 times 10, which is equal to 100. Okay, and so we're saying 1/3 base area 100 times height, which is 10.91 centimeters. Alright, so that we have 1091 all over 363 when you divide that 67 centimeters cube. Okay, so with this example, we've come to the end of this special class. It might really look difficult for a start, but with time and constant practice, you will grab every bit of it. Have a nice day. Goodbye.